right, welcome everyone. This first PowerPoint is called Purpose of Statistics. This is the first in a series of PowerPoints that I will be kind of doing a voiceover for EDU 8307, which is kind of also known as baby statistics. It's an intro to statistics. This is also the first time I've ever done voiceover, so I'm just going to treat it like I would any class, and if I have a little goof up in my voice or in what I'm saying, I'm just going to continue just like I would do for a regular lecture class. So forgive me for any goof ups. All right, the purpose of statistics. Why are statistics important? Well, bottom line is we're trying to make sense of numbers, usually large sets of numbers. If we only have a little bit of information or a little bit of data, we don't usually need to summarize that data. We can just say what it is, and I'll show you an example of that pretty quickly. But when we're thinking about statistics, a lot of people think math, but really statistics is a lot about identifying patterns and relationships in data, and again, usually large sets of data. And if we can take a lot of data and identify those patterns, we can start to make better decisions about whatever it is. So based on a lot of data, we're going to examine it for patterns and relationships, and then start to draw some conclusions about what is going on out there, whatever that situation is that you care about. So in this first example, we have a teacher who, for whatever reason, only has 3 students. So her or his students score an 85, a 90, and a 95 on some assessment. So if the teacher is standing out in the hall and his or her coworker comes by, how could this teacher describe the scores? Well, she could or he could say the average of the scores, the range, or there are only 3, so she just says, hey, my student scored an 85, a 90, or a 95. So as you can see in this case, when we just have a little bit of data, there's really no point in us running any statistics. We can just tell it. All right. On the other hand, if we have a situation more like this, which is probably a little more realistic, where a teacher has quite a few scores, now if approached with the idea of describing the scores, what could the teacher say? I'm going to have some examples here. What's the lowest score, the highest score, the average? How many A's, B's, C's, and D's? Or he could summarize and say 90% of my students pass, and so on. So all of those are statistics. The low, the minimum, the maximum, the mean, the frequency, percentages, percentiles, those are all statistical concepts. And it helps us communicate our data and our information in a much more concise manner. What I want you to know is that statistics is more than memorizing formulas. And in fact, I won't ask you to memorize any formulas. If you need a formula, I'll have it there for you, because, in the real world, if you are writing a paper, a journal article, if you're running your stats and you need a formula, you're going to go and look it up. If you're working on your dissertation and you need a formula, you're going to go and look it up. So I'd rather you understand what's happening within the formula than just worrying about memorizing it and being able to do the algorithm, but not really understanding what's happening. So contrary to popular belief, researcher judgment is a big part of statistics. So I think some people get the idea that statistics is more clean cut, it's more objective, that the researcher is able to kind of step to the side and just do statistics. But really what I think you'll come to understand is that you, as the researcher, have a big part in how your results come out, whether it's truthful, ethical, reliable, all those good things we want for the findings of our study, compared to some other decisions you might make that might produce more favorable results as far as your conclusions go, but may not have been the most ethical decisions along the way. And so we really want you to come away from here with being able to use statistics to better understand your data, to see those patterns and make informed decisions, thereby be able to answer your own research questions. But also, kind of where I was going with this before, be able to critically evaluate others' responses to research questions, rather than that methods section being the section in the journal article that you skip over. Now, at the end of this course and your next course, being able to really read through it, and even if you don't understand every single part, first of all, you could figure it out if you wanted to, but then also just being able to get an idea, whether a specific idea or even a general idea about whether that particular researcher used the correct statistic in the correct way and you can trust his or her findings or conclusions. Okay, another thing I want to point out is kind of the way we're going to think about statistics. So if you look first, this mathematical way here, we can think about statistics in a very formulaic, mathematical way. So this formula here is something you guys, I'm sure, have done lots and lots of times, and this is finding the mean or the average. So rather than call it the average in here, we're going to call it the mean. This X with a bar, that is the symbol for mean. So the mean is equal to the sum of all your scores divided by your number of scores. All right, very mathematical approach. So if I'm looking down here at my little example set of scores, I have a 1, a 2, a 2, and a 3. If I put that into the formula, I have the sum of 1 plus 2 plus 2 plus 3, which is 8, divided by the number of scores, which is 4. So my mean then becomes 2. All right, very mathematical, and there's absolutely nothing wrong with doing that. But then there's also this other way of thinking about the mean, and it's more conceptual. If you think about the mean, and in a later PowerPoint we'll talk about it, but if you think about the mean as the balance point of the distribution, the mean as balance point, so you're looking for the number around which the distribution is balanced. Okay, so if I take my same set of scores and I plot it, 1, 1, 2 2s, and 3, 1, 3, and you think way back to elementary school playground maybe, where you had a seesaw or a teeter-totter, teeter-totter, teeter-totter. Every time I say teeter-totter, I think of the Brady Bunch. I don't know why, but say you have a seesaw here. Where would that fulcrum be? Where would the fulcrum be for it, your distribution to be totally balanced? If you could see me in person, I'm trying to make the teeter-totter, or the could also be a lever. Where would you put the fulcrum for it to be balanced? Okay, it'd be right here at the 2. It'd be right there at the 2. So if we had the fulcrum here, you can think of this as a kid, even. You could think of this as a child and this as a child, and they're about equally balanced. So if they're sitting on this seesaw, that board's going to stay pretty flat. And as far as the mean being the balance point of the distribution, then 2 would be that balance point. Okay, so here we have a really mathematical take on statistics, using the mean as just a very basic example. And then we have more of a conceptual look at statistics here, just as mean as the balance point, really with doing zero math. And what I want for you is to be able to do the formula up here, but then to also know that this is what's happening. This right here is what the 2 actually means. It means the balance point of that distribution. So now your scores are equally distributed around your mean there. Okay, so we're going to look at it kind of in both ways. If we have to lean one way or the other, we're going to lean a little more conceptual and less mathematical, which I may have heard you cheer there a little bit. All right. I'm going to pull up another document here in a second, but looking at the big picture, we're going to spend about the first third of the course in this descriptive world, if you want to think of it that way. So no matter how fancy an analysis you do or how much data you collect, when you start to write up your results, you always want to provide the reader of a description of who your participants are. How did they do on this variable or that variable or this assessment or that assessment? Kind of in general, how do they look? You can think of this as some novels out there. As you get into the first part of the novel, the author spends quite a lot of time describing the setting and the characters because they want to paint that picture for you of what's going on. And it's the same thing when you're writing up the results for a study you've conducted. And if you're reading one, that writer should present descriptive statistics to give you an idea, to kind of give you a frame of reference for what you're going to talk about later in your paper or what they start to explain to you later. So that would be kind of this descriptive world. The other thing we'll do toward the second part of the course is look at inferential statistics. So we want to start to draw conclusions about a population based on sample characteristics. So this is where we'll talk about pulling those samples, and based on what our sample looks like, what can we then infer about our population? Hey, the last thing for this PowerPoint along those same lines, what I want you to begin to think about is this population versus sample idea. So sometimes when we think about population, we think census, and that is counting every single person, say, in the United States. Well, when we're talking about population, we're actually talking about whatever that group is you care about. So, for example, if you're doing a study on third graders in the state of Texas, that is your population. Then you will pull your sample from all of the third graders in Texas. Okay? Another example might be students, again in Texas, because we're in Texas, but you know this would apply to anywhere. But say you wanted to focus on Region 10. So Region 10, which is kind of part of North Texas, Region 10 graduating high school seniors who had to enroll in developmental courses during their first semester of college. All right, if that's who you care about, then you're going to sample from that group. Maybe there is a list, or you could somehow compile a list of all those high school seniors who had to enroll in developmental courses during that first semester of college. That's your population. Then you're going to pull your sample, however big, 20, 30, 500, whatever size sample you're going to pull from that population. So again, that population is just whatever group you care about. And that is totally defined by your research question and by you, the researcher. Okay, so we are off and going. I'm going to move on to PowerPoint number 2. And I'm trying to keep these to 10 minutes or less. So just bear with me as I learn this process.